Hi, we're going to begin a series of videos on the concept of rational functions. Over the next few lessons, we'll cover what is a rational function and how do we find its domain. We'll graph basic rational functions, y equals 1 divided by x and y equals 1 divided by x squared. We'll find vertical and horizontal asymptotes, find intercepts of a rational function, and finally graph transformations of these basic rational functions. So the first objective is to define a rational function and find its domain. Recall that a rational number is a ratio or quotient of two integers p and q such that q does not equal 0, right? So we're just looking at p divided by q where the denominator is not 0. Examples of rational numbers are 2/3, -3/5, or 0.33333, right? Because it can be written as a ratio of 1 and 3. We can have mixed numbers and so on. Even integer values are rational numbers. But more importantly, we're going to talk about a rational function. So a rational function R is defined as a ratio or quotient of polynomial functions. That is, R of x is equal to p of x divided by q of x, where p and q are polynomial functions and q of x is not equal to 0. We've actually seen rational functions and rational expressions prior to this, something like r of x is equal to x plus 2 divided by x minus 5. Right? That is a rational function. The numerator and denominator are polynomial functions. The domain of a rational function is a set of all real numbers excluding the values that make q of x equal to 0. That is, what makes the denominator 0. So we have to exclude these values, which are actually zeros of the function q. So in r of x equals x plus 2 divided by x minus 5, recall that we set the denominator equal to 0. We get x minus 5 equals 0, or x is equal to 5. So the domain is a set of all real numbers except for 5. We write that as negative infinity to 5, parentheses, union, parentheses, 5, comma, infinity, close parentheses. So more examples of rational functions and their domains. We have f of x equals 1 divided by x. That is the basic rational function. We actually saw that briefly in section 11. The domain of f is a set of real numbers except for 0. That is where the denominator is equal to 0. So that in interval notation is parentheses, negative infinity to 0, close parentheses, union, parentheses, 0, comma, infinity, close parentheses. G of x is equal to 3x divided by x minus 2. Very similar to the one that we just looked at. So the denominator is equal to 0 when x is equal to 2. And so the domain is all real numbers except for 2, written as negative infinity to 2, parentheses, union, parentheses, 2, comma, infinity, close parentheses. Then h of x is the quantity x squared plus 2x plus 5, all divided by the expression x squared minus x. So the domain of this function is all real numbers except for where x squared minus x is equal to 0. And this is a quadratic equation. We can factor out the x to get x times x minus 1 equals 0. So when we set each factor to 0, we get either x is equal to 0 or x minus 1 is equal to 0, which is at x equals 1. So we exclude 0 and 1. And recall that if you have trouble writing the interval notation, draw a number line, put those restrictions of 0 and 1, and think about an open circle at those points, but I can include everything before 0, between 0 and 1, and then to the right of 1. So this is written as negative infinity to 0, parentheses, union, parentheses, 0, comma, 1, close parentheses, union, parentheses, 1, comma, infinity, close parentheses. So in this example, we want to determine the domain of each rational function. And in example A, we have f of x equals x cubed minus x squared minus 9x minus 9, all divided by x squared minus 25. And so the domain excludes where the denominator, x squared minus 25, is equal to 0. And we can solve that by the square root property. We get x squared is equal to 25 when we add 25 to each side. And remember this, that if x squared equals a number, x is equal to plus or minus the square root of that number. So we get x equals plus or minus the square root of 25, or x equals plus or minus 5. So we have to exclude negative 5 and 5 from our domain. And so we write the domain of f as, well, think about this. So everything before negative 5 is negative infinity to negative 5, parentheses, union everything between negative 5 and 5, which is open parentheses, negative 5, comma 5, close parentheses, union, and then everything to the right of 5, which is open parentheses, 5, comma infinity, close parentheses. Now, part B, we have f of x equals x cubed plus 27, all divided by x squared plus 16. So again, we have a rational function, the quotient of two polynomials. We try to find where x squared plus 16 is equal to 0. And if we solve this by the square root property, we can subtract the 16 to get x squared equals negative 16. Then x is equal to plus or minus the square root of negative 16. Remember what the square root of negative 1 is? Exactly, it is I. Therefore, the solutions to this equation are x equals plus or minus 4i. But because the solutions are complex solutions, there are no restrictions on the domain of this rational function. So therefore, the domain is negative infinity to infinity, right? There's no real numbers that we need to exclude. And another way you can think about this is that x squared is always positive or 0, right? And when we add 16 to it, it's only going to get larger in value. It never will reach 0. And so the domain is all real numbers for that function.